In this lesson, we're going to look at ideal gas behavior. Now, the vast majority of gas samples behave under conditions that are so close to ideal behavior that we can ignore any deviations from that. But what we want to look at is how do we predict when a substance is going to be most like an ideal gas? So we have to worry about two factors. We have to worry about pressure and we have to worry about temperature. So we're going to look at pressure first. When I look at the pressure of a gas sample, here we have some gas molecules in a container, and the pressure occurs when they hit the sides of the container. If I compress this and increase the pressure, I've not changed anything else about the amount of sample or the temperature, I've just increased the pressure, what I see is that now the molecules are hitting the surfaces more often, and so I have increased the pressure. As I increase the pressure, I'm going to push those molecules closer together and they are going to interact with each other more. The basic principle of ideal gas behavior is that we minimize interactions between molecules. So ideal gas behavior, we want to minimize interactions, okay, between those molecules. So if I look at my pressure situation, what I'm going to see is that if I have a lower pressure, I'm going to have something that is more ideal, and at a higher pressure, it's going to be non-ideal or more non-ideal. There's not a hard line of as where it goes from being ideal behavior or more or non-ideal behavior. It's a gradual transition between the two. And so we call this non-ideal or more like real gas behavior, where molecules are actually interacting with one another. The other issue we look at is heat. So when we look at molecules that are moving slowly, what we see is they've got time to hang out with each other and time to interact. So as we have our very slow molecules, what we see is they interact more, and as a result, they're going to have more non-ideal behavior. I can say more non-ideal. And as we increase the temperature, molecules are moving faster. They simply aren't near each other enough to actually interact with one another. And so we say, well, they have more ideal behavior. So the conditions that give us most like ideal gases are low pressure and high temperature. For low pressure, molecules are far apart from one another, and at high temperatures, they're moving fast and aren't unable to interact.